Okay, um, welcome back everyone. And today I want to have this hopefully short, quick conversation about the Three Sigma rules. And this is something we use when we're working on statistical analysis and we want to detect and or remove outliers from our data set. So basically, if you think about it, most of the time we try to understand trends as if they are coming from a normal tendency or like a normal distribution, right? And sometimes when you don't have something that you can describe with a normal distribution, what you do is you use a normal transformation like the anamorphosis transformation to bring it back to a normal distribution. Run your test or analysis on that normal distribution, then you have the output from your modeling exercise, and you do the back transform to get the data into the original distribution before you run your interpretations. So whenever you're doing something like that, there is a step, at least I believe most people will recommend cleaning your data before you do anything else with it, because especially if you have like a human driven data collection step, we know we are human and we are full of flaws. So you most likely will end up having something which is not normal, like an extreme value or an outlier or something like that. And you want to be able to remove it before you run your modeling. And so today, what I want to talk about is the three sigma technique, which is basically thinking about how the number distribution behaves, like the shape of that curve, and understanding that at some point the values that you have after a certain range or a certain limit can be considered extreme values compared to the remaining set that you have in your database. And uh, so the way I will do it is I will just show you a short example of something that I made in MATLAB just to explain, and it should be very quick and very simple. So see you soon. So I have everything prepared already. I didn't want to type and show you how it works because I feel like for some of these topics, it's easier for me if I can just have the script prepared and I will just walk you through and show you how it works. And while I'm doing it, I can provide explanations, so it's easier for me. So yeah, let's first of all let's go back here, and this is what I was talking about. You have the data set in the beginning. It looks like this. And remember, like I said, if you have something which is not like a Gaussian distribution, you can always use transformation to bring it back to a Gaussian. When you're done your modeling, you can back transform everything you have into the original distribution before you run interpretations. So we try to use Gaussian distribution as most of the time because of the symmetry, right? It's a very good property when you want to talk about things like this, because then if you compute, for example, the z-score, whether it's a negative value or positive value, you can provide the same interpretation, which is not always true if I do it, for example, with the gamma distribution. With the gamma distribution, it would be harder for me to use something like this in order to understand what is an extreme value, because it's not really, we don't have that symmetrical property for gamma distribution. So we usually call it the three sigma rule because the idea is everything that is out of this range can be considered an extreme value. Some people use two sigma. I think it's dangerous because, I mean, you will see when I think two sigma can be dangerous. Three sigma already is. I don't like it in because for some application, three sigma is not enough. You need to go. You need to make it a bit wider. So like four sigma, for example, and that's why I try to emphasize the fact that this should be adapted to a specific application. So depending on what you're doing, you should come up with your own rule. So if you want something pretty aggressive, maybe you will use one sigma, right? But if there is a specific reason why you want something more than three sigma, then you should go for it and say, okay, usually people use three sigma, but I want to use something like four sigma. Completely fine. As long as you have uh, enough motivation to say you want to use something different, I think you should be fine. And you need to make sure those motivations at least make sense to you, because you have to be able to explain those to you before you can explain it to someone else, right? So it's very easy. Here you will imagine having random vector with values between 1100 and 2600, right? And you can compute the mean of that vector. You can also compute the standard deviation of that vector. Now we have mu and sigma. So now, remember we said the random vector is taking values between 1100 and 2600. So what if I have something which is zero in that set instead of something between 1100 and 2600? And again, remember here what I'm trying to do is the mean that I have here is like a sampling mean, and the standard deviation is like a sampling standard deviation. Those are not real, but the idea behind is I assume I know the real mean and the real standard deviation, right? And I try to compare what I will have as a z-score with the properties of a normal distribution. So now the z-score, if I have something which is like if I have a zero value in my vector, the z-score for that is going to be this negative 4 something. So if I look back at the Gaussian distribution curve, we are after this point. So it's like if mu is 0 and sigma is 1, that is negative 3. So negative 4 is going to be after negative 3. So it's extreme, right? And makes sense. It's 0 compared to 1100 and 2600. I think it's extreme. But if I want to see the same thing with 500, now it's negative 3. So it's not really like that's, and if you think about it now, we have 500, we have 1100. Someone would say, well, 500 is kind of too small compared to 1100. I can say no, it's not that small. Like it's really a matter. It's just like about 50% smaller, right? It's like if you have 1,000 and I have 500, I am halfway, right? So yeah, that's why I said it's really based on applications. Someone would say it's extreme, someone else would say it's not. So always make sure you can explain why you use the 3 sigma or the 4 sigma when you want to establish this rule to eliminate outliers, or at least to detect them and call them outliers. So that's it. That's how simple it is. Very simple. You see, it's just knowing how to compute the sampling mean, knowing how to compute the sampling standard deviation, and understanding how to use the rule, and that's it. Next time, maybe we'll talk about the principal component analysis, which is also something very interesting. But most of the time, that one you want to use it when you have like several entries in your database, and at that moment, a single value is not enough to tell you if you have an extreme entry in your database or not. You really want to look at the entire behavior, right?